morning, welcome to lecture 38, Logistic Regression, under module 8, Predictive Safety and Risk Analytics 1. Logistic regression is a very important topic, and you know that it is very widely used one, particularly in machine learning domain. The use of logistic regression is enormous because of its versatility in capturing the categorical response variable. So, what are the top different concepts that will be discussed in this class? One is generalized linear model. This is a class of linear model, and I will relate this with logistic regression model also. Then we will not discuss much about parameter estimation, but I will tell you the general concept of parameter estimation. And after that, once the logistic regression model is fit, how do you know model fit to the data or not? And at the same time, the logistic regression coefficients as well as the findings should be interpreted, and that is what will be discussed. And if there are more than two classes for response variable, so how logistic regression can be used? Originally we start with two class model, and then at the end I will tell you what are the other variants of logistic regression. We are discussing the predictive analytics, and under this we are basically considering the supervised learning part and in the form of either classification or regression. Logistic regression is a technique which can be used under both the classes, means it can be under regression or it can be under classification, depending on the purpose, how are you using it. Okay. But in general, as logistic regression takes the categorical dependent variable, so if you consider categorical variables and you want to predict the class, then it is basically it falls under classification. Okay, whatever may be the issue is that supervised learning from regression and classification point of view. So, you will understand regression just where we compute desired output which comprises one or more continuous variables. But when we talk about classification, we basically have the dependent output variable or dependent variable which is basically have different classes, means the y has categorical in nature. So, that is what under right hand side we say dependent variable is okay. No, this is another concept. What is this concept? That if I say I have two types of variable, one is y, another one is x, and I am interested to know what is the y is function of x. This variable is known as target variable or response variable. This variable can be talked about that predictor variables or explanatory variables or independent variables, and this also similarly can be said dependent variable. Now, seeing the nature of the function given y equal to fx, that means y depends on x, that is why y is dependent. And second is we want to predict y, or we want to understand the value of y, and that is why the response, and x basically used to predict y, that is why predictor. X at the same time may be used to explain the variability of y, that is why explanatory, and on the other hand x is not dependent on other x variables or y variable, that is why independent. So, this is basically the general, I can say this is the general that function or relationship what you want to capture. You can capture this in terms of regression or classification. If y is continuous regression, if y is categorical, that will become classification problem. But when we try to develop some kind of regression or classification model, the issue is that y is the random variable y, it can be normally distributed, may be non-normal. That is the issue. So, if it is normally distributed, then the regression type of multiple linear regression is fantastic one. But if it is non-normal, then the multiple linear regression kind of things you will not be able to use. Okay, so the error variable should be normally distributed, that will happen. Now, what is the way out to this? Basically the solution to this is you try to find out a model which will take care of both the normal and non-normal y or dependent variable. So, that is known as generalized linear model. What generalized linear model basically does, it basically find out that some link function with the link will be with reference to y and x with some kind of function in such a manner that if y is normal, one kind of link, if y is non-normal, depending on what kind of non-normal distribution it is, the another kind of link will be found out and or will be used. So, GLM essentially consists of three components. One is the random component, systematic component and link function. Now, what is the random component? If I say y is function of x, means I want to relate y with x in some way. Here this y variable is basically random in nature, okay, and it basically attributed to certain probability distribution. So, that randomness we are talking about when you capture, that is the random component part. What is the systematic component? The systematic component is, we are saying find the, if I consider y variability, so variability of y, I can find out it has two parts. One is something which could be explained by x, and something which is again random could not be explained by x. So, that means that what is possible or explained by x, that is the systematic part of it. What is not possible, that basically that actually what is not possible, the random part of y will not be possible. So, that means actually that is why many times we say data equal to pattern plus error, data equal to pattern plus error. This pattern is the systematic component and error is the random component, and as y is composed, y is the data in our case, in the sense we are basically interested to understand the behavior of y, that sense I am talking about. X is also data part, but here understand the use of x is used to understand y. So, that is why y has pattern plus error, and as a result y is having its own distribution also. Now, the third one is basically what we are basically talking about here. Third component is the link function. The link function basically what it does, it basically identify a certain function in such a manner that you can if you read that the mean of y as a linear function of x. instead of y, if I write mean of y, which is a linear function of x, so x predicted variable x, so the purpose will be served. So that is the issue, and these things, basically all these things. So I will now show you one case of that, what is this GLM model and what are the different components and how the normal y and non-normal y can be captured with the generalized linear model concept. As I told you, y is the important part. So let y1 to yn, these are the independent observations, and for the time being you just think that as each independent observation is a random variable, they have corresponding mean mu1 to mu n, and also consider that y1 to yn, each one of them coming from exponential family of distribution. What is exponential family of distribution? So that you please Google it. You Google it, find out what is exponential family of distribution. So y coming out of one of the exponential family of distribution. Now what are the other important, that we have x1 to xk, this kind of predictor variables are there. What GLM will do? GLM will create this. What is this? Y is, I told you that the pattern plus error. So each stands for error, eta stands for pattern or the systematic component. Now this pattern part or the systematic component is linked with the predictor variable in terms of x transpose beta. This is x transpose beta, or we can write x transpose beta in this manner. Now what is the beta? Beta is the relationship coefficient. Okay. Now issue is that what will be the eta value? So that function is called link function. Okay. So how eta is determined, that is the link function. Now we are saying that G mu, where mu you can understand the mean value, expected value. Now eta I is a G mu I, basically the ith observation, the systematic component, that one is function of the mean of that particular observation. So this is basically important part. You have to understand that what is. Now issue is, if I can identify G mu for a particular family of distribution, then my purpose is served. Okay. So now depending on the y coming from which distribution, the G mu will be determined, and that is given in this site. If y coming from a normal distribution, eta I equal to mu I, so that means G mu I equal to mu I, basically that is identity link. If suppose y is binary in nature, so that means ultimately the number of occurrences finally become binomial. So that link, that y will be binomial kind of variable. So then the link will be used eta equal to log of pi I by 1 minus pi I, where pi I is the probability that it belongs to that particular group, maybe with 1 or 0, which one is your importance that you do. This kind of link is known as logistic link, and that is why the logistic regression that you will find out. But suppose y is count data, so in that case the count data will basically follow Poisson distribution, so your link is log link. Why we brought under logistic regression the general linear model? Just to tell you that it is not the logistic regression which basically only takes care of the non-normal data. Logistic regression takes care of the data when the y variable is binomial in nature or multinomial in nature, depending on the number of classes for the y. But if y is non-normal but it is Poisson, then you have to go for Poisson regression. If it is negative binomial, you have to go for negative binomial. But all those things under one capsule, the generalized linear model, you can consider. Okay. So, now henceforth I will not go for this GLM part. Now, I will straightway go into the logistic regression, primarily the binary part, and then at the end I will tell you some of the variants of logistic regression. So, now you consider that your y variable is binary in nature, that means it can take value 1 or 0, something like this, safe or unsafe, something like this, success and failure, something like this, good or bad, whatever this way you can think of. So, when y is labeled categorical response, so you will go for logistic regression. Now, the logistic regression can be of binary logistics, can be polytomous logistics, can be order logistics. So, there are many variants, but here we are considering y two classes 1 and 0. And what about x? X is the predictor variables. So, the predictor variables can be continuous or categorical in nature. So, that is your input. What is the output? Obviously, output, when you say coefficient of predictor variable, this is nothing but the model itself is the output. When I say model is the output, that means the relationship you are getting with the coefficients. In addition, from interpretation purpose, odds ratio for every predictor variable is used. Obviously, fit measures are required because this will tell you whether model is fit or not, and at the end also you want to see that if there is a new observation, what is the probability that it will fall into a particular class. Here if it is binary, for the 0 class or 1 class, that is also output. Okay. And what are the things you have to do? So, as I told you, first you have to understand the link function and systematic part, then only you will be able to use logistic regression, and then you have to develop certain parameter estimation algorithm. You have to compute the parameters, and then obviously some kind of classification approach you have to do, because here what is actually happening, if there are two class, for a new observation you are saying it will go to class 1 with certain probability, class 2 with certain probability. Now question is that what is that probability value? If it is above that, we say it goes to class 1, if it is below that it goes to class 2, some kind of thing. So, that means some kind of rules also you require to set in order to have proper classification, because later on I will show you later on that logistic regression give you the probability value. Okay, probability value to fall into a certain class. Suppose if I say it is class 1 with probability 0.05, will you consider it is class 1? Because if there are two class, then that is a probability that 0.95 it will go to the other class. So, obviously 0.5 is probably the value which may be considered as the threshold value. If above 0.5, then it will fall on that class which one you consider as y equal to 1 or y equal to 0. If it is less than, it will go to the other class. But if it is more than 2 class, then you cannot say 0.5. So, it is again another important issue. Anyhow, for the time being, you please understand we are considering 2 class, and I will not go further into explanation of the link function, but please understand in logistic regression I told you that link function is basically log link, a binomial link, where that link function looks like this, and with this, if you relate this is eta, log of mu by this equal to eta, and that is basically g mu, then obviously you can finally with algebraic manipulation you will know that expected value of y will be of this nature. You can manually do, absolutely, you will find out the similar things. Now, as I told you that the eta part is related to eta part, here you just see that let me go back, here you see eta g mu, when if it is logistic links pi I by 1 minus pi I. So that sense, so that we link with here with mu, okay, g mu. So now again I am going to the next slide, where we are basically trying to talk about this part, that eta is x beta, x transpose beta. So this one we are basically considering here, and let me talk to you. Yes. So finally, if you try to find out the mu, see pi equal to e to the power g mu by 1 plus e to the power g mu, and when g mu is eta and eta equal to x beta, if you put all those things, you are getting this. So your that probability of presence, here we are saying presence or absence. So y, if y equal to 1 if present, and y if present if y equal to and 0 else, let it be like this. So then Ix is basically probability of presence where at predictor level x. So x is the predictor variable, so that you are now relating that systematic part with eta, and finally the probability with the x variable, predictor variable. I hope that it is clear to you. In the first equation or first model, we consider only one x, that is why the e to the power beta 0 plus beta x. In the second one, you consider more than one, mean k predictor, so that means e to the power c, this is basically beta 0 plus beta 1 x1 like this, and by this is the formula. The interesting part is, so or you can write like this, e to the power x beta by 1 plus e to the power x beta, but you have to think of matrix multiplication point of view, otherwise I think we have written x transpose beta, but if you divide numerator and denominator by e to the, it can be like this, 1 plus e to the power minus x transpose beta. Okay, or you may find out, suppose if you write like this, suppose this is the case, what is the 1 minus pi, then it will be 1 minus e to the power x transpose beta by 1 plus e to the power x transpose beta, then this will be 1 plus this minus this, so 1 by 1 plus e to the power x transpose beta. Now if I create pi by 1 minus pi, what will happen then? So that means it is e to the power x transpose beta, this one is this, by 1 plus e to the power x transpose beta divided by, what is this, 1 by 1 plus x transpose beta. So x transpose beta will be cancelled out, so this will become e to the power x transpose beta. So then what is this g mu? G mu will become this one, and and in the previous slide, let me check what we have written, am I telling the wrong thing? So g mu e to the power x, that is x transpose beta, so e to the power x transpose beta. Okay, so the interesting part here is this pi by 1 minus pi. What is, if there are two class, if pi is probability of presence, then 1 minus pi is probability of absence. So that means with reference to absence, what is the presence, this ratio is coming here. Okay, so that we will discuss under odds ratio. This pi by 1 minus pi, this is basically known as odd. Okay, so let us go to the next slide. Now, how do you estimate this? Parameter estimation, I just intentionally kept it blank, Actually, when you talk about parameter estimation, here we will be going for maximum likelihood estimation. Maximum likelihood estimation, MLE. So, in MLE what is required? First you know that pi, that x, that particular formula distribution you have, and it is true for each of the observations. So, you will finally create I equal to 1 to n observations. So, that means the from probability function, logistic function you have, from the logistic function likelihood function you can write down the same manner. For I equal to 1 to n, that you go on multiplying, and finally log likelihood value will become equation will be found out, and then you take the derivatives and first derivative put equal to 0, or in this manner things will continue. But here you will not get closed form solution, you will get some kind of equations which cannot be solved just like the way we do in algebraic kind of thing. Suppose if I know a equal to b plus c by 2 or something like this, no, it is not that simple. You have to use some kind of numerical methods like Newton-Raphson optimization method or something like this, and using this you will be able to estimate the parameter. Finally, the log likelihood function will be a function of the parameters to be estimated. So, that complex issue I intentionally kept out, but please keep in mind MLE case the log likelihood function will be preparing, which will be a function of beta values, which are nothing but the coefficient, regression coefficient values attached to the predictor variables including intercept, which is beta 0. Once you estimate the beta values, your fit measures is very important one. That means if I go back, I am going back, you see, consider the second one, beta 0, beta 1 to beta k. So, beta 0 to beta k you are estimating, and when you are estimating beta 0 to beta k, whether each of the parameter values are significant or not, that you require to test, that is known as hypothesis testing. Beta k equal to 0 to beta k not equal to 0, that is the hypothesis, and there are Z test statistics you can use, there is world statistics you can use. It is clearly written that what is the Z statistics value, what is the world statistics value. Only thing you understand, beta k is nothing but, beta k cap is nothing but the estimated value of beta k, and sigma beta k cap, sigma cap beta k cap is nothing but the variance, standard deviation of the estimated value beta k. So, these things if your software will give you, if you are not able to do manually, and using this you will be getting the that statistics values. So, either Z statistics or world statistics you use, and world statistics basically follow chi-square distribution, and Z statistics you know that unit Z distribution, the unit normal distribution that will follow. Both the things will give you more or less similar results, and using this you will understand that which of the predictor variables are significant or not. In addition, basically what you may be thinking, okay, each of the predictor variable, maybe some of the predictor variables significantly contributing, doesn't mean that your model is very good, but the model fit point of view means how much error it is basically coming out of the that prediction. So, that kind of things using the training data set or test data set, if you do, so either in the chi-square like Pearson chi-square test, or you can do Hertzsprung-Lemesurier test, and the formulas are given here. So, using these formulas you can find out what are the overall model fit, and if the model is overall model is not fit, so it is better not to use. Okay. So, in both cases p value is less than level of significance, that indicates that model does not fit the data. That means we are basically considering the, suppose the logistic regression, here we are considering logistic regression fit to the data, that is our null hypothesis. Alternate hypothesis is that logistic model, the regression does not fit to the data. So, as a result, if p value is less than alpha predetermined values, so we are saying that model is not fitting. If p value, the higher the p value, greater the model fit, but from the individual parameters point of view, it is not the case, it is the other way around. That means if alpha value is, or the probability value here is your less than the cutoff significance level alpha, then the fit is this. That means that particular parameter is significant. Okay. With this, I will just explain about odds ratio. Now, question is, in the logistics function, you have seen earlier, I have said pi by 1 minus pi. What is the meaning of this? If I say pi is the probability that y equal to 1, then 1 minus, and if it is two category 1 and 0, then 1 minus pi is equal to probability y equal to 0. So, that means you are creating a ratio of two probabilities, probability of presence by probability of absence. So, that is why it is odds. Now, when you talk about odds ratio, it basically bringing another thing into consideration, that is known as predictor variable. If I consider a predictor variable x, and if I consider the value of predictor variable x is x, what is the odds? And if I increase the predictor variable value by 1 unit, like x equal to x plus 1, what is the odds? So, if we take the ratio of odds of x plus 1 by odds of x, so then that will become odds ratio. What it will give you? It will give you, if you change the predictor variable value by 1 unit, the change in the ratio of probability of presence to probability of absence is odds ratio. Okay, so that means now beta, you will, if you just do little bit of algebraic manipulation with the odds ratio, and pi x already given to you. So, odds are already there with the logistic function. If you use this and you create odds x plus 1 by odd x algebraically, I think assignment can be given in this manner. So, e to the power beta, you will find out the beta what you computed, this beta k, these basically beta are basically talking about odds ratio. Means if I change x, the one predictor variable values by 1 unit, what is the change in odds of the classification variable, or other way I can say target variable or the response variable. That is very interesting. And if beta is 0, then what is the issue? The odds of the probability are the same at all level of x, not contributing. If it is greater than 0, then e to the power beta is more. So, that means it is increasing the probability odds towards the presence. If it is less than 0, it decreasing the odds towards presence, means increasing the odds towards absence. So, this is the way you have to understand. When we have more than one predictor variable, you use the term k, odds ratio k means for the predictor variable k, but the interpretation is similar. Okay. So, with this I now go to that another kind of measure for the classification problem. Actually, what will happen when you are doing the testing with the data? So, that means actually in the test data you are using the x side of it and asking your logistic regression model tell what is the class value, but actual class values are also known to you. As a result, what happened for the test data set, or it is better to use for the test data set, training data set also you can do this, but for the actual level what are the yes or no and predicted level yes or no, then what will happen, you will find out that actual predicted matching for certain number of observation, these are known as true positive, or not matching, these are known as false negative, or maybe actual level is no but prediction is talking about yes, not matching, false positive, or both no, that is true negative. So, this kind of confusion table you can create, and the total will be obviously the true positive plus true negative plus false negative plus false positive. So, that using these values you can create several accuracy measures like accuracy, that means true positive plus true negative by total, precision true positive by true positive plus false positive, recall equal to sensitivity equal to true positive rate, means true positive by true positive plus false negative, and specificity true negative rate, true negative by true negative plus false positive. So, these are the formulas I have taken from the literature. If there is any mistake, please correct me in the discussion forum. But you understand that these all those values lie between 0 to 1, and if it is close to 1, that is better. All the accuracy measure range from this. Okay. So, this is another way the understanding the predictive capability of the logistic regression. In fact, this will be useful for classification tree or other any kind of classification problem. This kind of confusion table you can generate, whether you are using logistic regression or you are using classification tree or you are using support vector machine, but this confusion matrix is always possible to compute, and using the different accuracy measures you can judge whether the model is useful for prediction or not, prediction as well as classification or not. So, in addition, as I told you that depending on the nature of the y variable, if there are more than 2 classes of variable y, so then polytomous logistic regression model will be used, and in addition, that if the classes are ordered, then order logistic regression model will be used. The formula is given here as well as some example is given here. For example, polytomous logistic regression, for example, we are interested to know certain type of accident like derailment related accident, fall from height related accident. There we cannot make any order, but some kind of categories can be found out. So, then that will be I can say when it is more than 2 categories polytomous. And but if you think of that you are predicting severity, predicting risk, then what will happen, you may find out that high, low, medium kind of some order categories, more than 2 order categories you can create. So, in that case what you will be doing, you will be doing ordinal logistic regression. So, it is a huge subject. So, there are so many issues we cannot complete within a short period of time, but I have given you some idea, and this idea or the concept what we have discussed here, that is really will be really useful to you. And at the same time I want to tell you that the machine learning approach, when you are using data set, training data, test data, and you have to verify the model using training and test verification is most important compared to training. And then after that new data will be coming, and you either you will predict the value or you will classify the new observation in the given classes, whichever is appropriate. So, those things are repeating things because these are all part and parcel of any predictive analytics model. Okay. With this, see the different references, and thank you so much for your patience. Thank you.